This conference will now be recorded.
Okay, so good morning to all. Today we are going to see our routing numericals, not more than that. So it will take almost half an hour to 45 minutes, not more than that. So here the thing is that this is the assignment what I gave you. Okay, so I hope almost everybody done this, but and even I want to solve this for you, so it will be easier for you for understanding. So routing numericals, so we have given two topics, that is one is for RIP, routing information protocol. So this is the network which I provided you, that is the routing table of F. So the routing table, which is the diagram we are given. So this is the diagram, and we said that we have to find the routing table of F. So for the node F, we have to find the routing table. So if you see the network, the node F is directly connected with C, E, and G. This node doesn't have any information about A, B, and D. So that is what we have to update. So to start with the solution, so we have the network. So I hope in the top corner I have the network for your reference. And now the step one is that we have to initialize the routing table for all the nodes, okay, like from A, B, C, D, E, F, G. So when the nodes are directly connected, so if you take the routing table of A, see here we have all the nodes, that is we have three values in the routing table, that is 2 connected to, and the cast. What is the cast to connect with this particular node? And then what is the next node? That is the intermediate node. Okay, so for routing, the routing table of A is something that, so from A to A, if you want to go to A, from A the cast is 0 and there is no intermediate nodes. And for B, that is from A to B, the cast is 3. So no, it is directly connected, so there is no intermediate nodes. And to C, the cast is 4. So see here, A is connected with C with the cast of 4, and all the remaining nodes like D, E, F, and G, they are not directly connected. So the value, the cast of those nodes from A will be considered as infinity. Likewise, we have done the same thing for B, C, D, E, F, and G. So for all the remaining nodes, we have given if the node is directly connected with the corresponding node, the value, the cast will be entered. Otherwise, we will place a infinity symbol. So if you consider a routing table of B, B is directly connected with only A and C. So A, the value for A is 3 and C is 2. And from B to B, the value is 0. So 3 values will be in the routing table and all the remaining values will be taken as infinity. So same as that of C. So if you see here, the value of C, A, it is connected with A, it is connected with B, it is connected with D, it is connected with G, and it is connected with F. So all these values will be entered in the cast locate column, and the value of E in the cast column will be infinity. So this is the first step. So you have to find the routing table for all the nodes that are present in the network. So if you consider the next step, we need to update the routing table of F. So just we need to update it. So if you see here, there is a thing which you have to consider. So which routing table I have to select. So for example, if you say F is connected to 3 nodes, that is E, G, and C. But it doesn't have any information about A, B, and D. So now I have to take the routing table of C so that I can get the value of A, B, and D, because C is directly connected with A, B, and D. So that is why I have to select the routing table of C. So now you have to, now if you see this particular slide, you can see that we have received the routing table of C. That is this one, the table which have these values, that is A, the cost is 4, B2, C0, D3, E infinity, F4, and G3. Now I need to modify the routing table of F using this routing table received from C. So modification is nothing but just in the next column, you have to place all, for all the rows, you have to place the value C, which means that from F through C, I'm going to all the nodes. So the thing is that, see here, from F to C, the cost is 4. So just in the cost column, add 4 to all the values. So now see here, A is 4, so make it A8. B is 2, make it B6. C is 0 there and make it 4 here, and it should be like through C. And then D is 3, so just add 4 value to that, so it will be 7. So infinity, 8 and 7. So now this is our modified routing table based on the routing table received from C. So now I have to compare the original routing table of the initial routing table of F and the modified routing table of F. So when we compare this, we have to consider the least cost. So if you consider here, we have 8 for A, the cost is 8, and through the node C, the intermediate node is C, but here we have the value infinity. So I have to take the value 8 and I have to take the value C. So that is what I have given in the first entry. So 2A, the cost is 8 and the intermediate, that is the next node, is C. When you compare the second one, here B is, the cost is 6 and it is through C, but here the value is infinity. So I have to take the value B. So B, the cost is 6 and it is through the intermediate node C. Now we have C, the cost is 4 and through C. Here, if you see here, the value of C is, the cost is 4, but we don't have any intermediate value. So we have to take this value. If both the values are same, but we here in the initial table, we don't have the intermediate node. So we will take that value. So likewise, D, here it is 7, here it is infinity. So I have to, obviously, I have to take the value 7. And E02, everything we have 202. So EFG, okay, for the node EFG, the value is 202. So which is the smallest value when we compare from the modified routing table, because here for E it is infinity and for F it is 8 and for G it is 7. So 202, that is a value, the smaller value. So I have to take this. So now the final routing table of F is A is 8, B is 6, and these are through C, and then C is 4, there is no intermediate node, and for D it is 7 through the intermediate node C, and for E, F, and G the values or the cost are 202 and there is no intermediate value. So this is the final solution of our problem for routing information protocol, that is RIP protocol. This is distance vector routing. Okay, so this is our first part. In assignments you have two questions and this is the answer of the first one. And next one, path vector routing. So in path vector routing we are going for OSPF, open shortest path finding. So the same network we have given for you, and now we have to consider, that is we have to find the routing table of node E. So now here to start with, the first thing is that we have to finalize the root node. So here we have to find the routing table of E. So now our root node is E. So that is why I have made this particular node in blue color. So to identify that this is a root node. And if you see here a table, we have two columns. One is tentative list and another one is a permanent list. So if I consider E as the root node, then I have to place that value in the tentative list. The value is nothing but the node name and the cast. So for E, to go to E, the value will be 0. Okay, from E, I need to go to E. So the value is taken as 0, that is E comma 0. And the permanent list will be empty. So for the first time, the permanent list will be empty and the tentative list will be the root node. That is, in our case, it is E, and the cost to reach E from E is 0. So this is our first step. Now, second step. So now we need to find all the neighbors of the root node. So now the root node is connected only with F. So F is my neighbor. So I have connected. So if you take this one, actually I think I have missed one diagram. So this will be the steps. These two will be the steps. Actually, I have missed one step. So here, if you see this one, so for E, we have the neighbor node is f of 2. So f and the cost for reaching f from E is 2. So I have placed that in the tentative list and I have moved the root node to the permanent list. This is our step 2. Okay, so E of 0 and the permanent list will be empty, which is the first step. In the second step, we will be adding the neighbor of E, that is E is connected only with F. So this will be added in the tentative list and then the root node is moved to the permanent list. That means if you add the neighbor of a particular node, that is E. For E, F is the neighbor, then you can place the root node to the permanent list. So now if you consider this one, f of f comma 2, which is in the tentative list, then I have to find who are all its neighbors. That is, f is connected with G, C and E, but E is already in the permanent list or in the tentative list. So I'm not considering this particular connection. So I have to consider only these connections. So I have C comma 4 and G comma 2. So now we have to move the node F to the permanent list because we have added its neighbor in the tentative list. So now we have C of 4 and G comma 2. So now we have to consider among these two, that is C and G, which one has the least value? That is, C have the cost 4 and G have the cost 2. So in our next step, we have to consider the G because G is having the cost 2, which is the least one among C and G. So now G will be added to the permanent list, and for G there is no neighbors because it is connected with, okay, right, okay, it is connected with both G and F. So F is already in the list, but the thing is here, see here, I have made a mistake here because from E, okay, correct. Whatever I did is correct because the cost will be high. So now see here, if you take the cost of C, okay, so here it will be 4 and sorry, from E to F it will be 2, F to G it will be 2 and here it will be 3. So the cost will be 7. So already I have C with the value less than the value, that is with the value of 6. So there is no new neighbors I have to add for G because G is connected only with C and F. So I am taking only, thus I'm moving the value of G to the permanent list from the tentative list. So now I have only one node, that is C, in the tentative list. So in the next step, I have to add all the neighbors of C and I have to move the node C from tentative list to the permanent list. So if you see the diagram here, see I have added all the nodes with their cast, and I have to move the node C to permanent list. So now my tentative list have A of 4, B of 3 and D of 2. So we have three nodes A, B and D. So now we have to decide based on the cast value. So among these three nodes, D have the least cast, that is 2. So in the next step, I have to add D to the permanent list from the tentative list. So now my tentative list will have A and B. Okay, so now again we have to check which one is the least one. So if you can now in this stage, if you check, D is not connected with any other node, so there is no neighbor to add to the tentative list. So now we have A and B. So A the cost is 4 and B the cost is 3. So B is having the least cost, so B will be added to the tentative list. And finally, we have only one node which is left in the tentative list, that is A of 4. So in the last step, that should be moved to the permanent list. Now our tentative list is empty. So we have to do this step until this level. That is, we have to make our tentative list empty. So it means that we have come across all the nodes. So now if you see this particular diagram, if you see this particular network, so E is our root node. From E, we can reach all the nodes only through a single path. So from E to all the other remaining nodes, we have a single path. So for E to F, this is the single path. For E to G, this is the only path. That is E, F and G. For E to C, I have F, C. E to A, I have to go for F, C, then A. And same as like that to B and D. So now we have a network which have only the single path from every source to the destination. So here the source is the node E because we have taken E as the root node, and all the remaining nodes are having a single path from the source. So if you compare the original network which we had and that network which we receive now, you can find the difference. See here in the original network, we have two paths. That is, if I want to go to E to C, I can go to F, I can go to C, or I can go from E to F, then G, then I can reach C. So there are two different paths we have in the original network, but now we made that every destination have can be reached by a single path. So the final outcome. So what will be the routing table of for node E? So for this particular network, that is a network which we have given initially, the node will be like this. So for to reach A, so to reach A, it will be like this from E to C and C to A. So if you see here, you can see very clearly here, this is from F. So here it is the cost is 2, here the cost is 4, and here the cost is 4. So 4 plus 4, 8, 8 plus 2, 10. So for reaching B, again 2, 4, and then 3. So it is 9. So 4 plus 3, 7, 7 plus 2, 9. And for C, it is 6. And for D, it is 6 plus 2, 8, and for E it is 0, and for F it is 2, and for G it is 4. So this is what we have get the final routing table for node E. And if you see the column for other nodes like E and F, because E is directly connected with F, so for E and F, the next node column will be empty, and for all other node, the next column will be F, because our path is all through F. Only through F I can go to C, I can go to B, D and G. So it is mentioned or it is noted that the next column, that is the next node column, will be F for all the nodes other than E and F. So this is all about our assignment. So this is what the assignment we provided you, and this is what the numericals we have.